Hello and welcome. I'm Dr. Pauline Fu. In this lecture, I will go over some problems for model building. So first question is about a study of high-pressure inlet fogging method for a gas turbine engine. The heat rate was measured for each in a sample of 67 gas turbines. Other variables measured including cycle speed, inlet temperature, exhausting gas temperature, cycle pressure ratio, and air mass flow rate. The data is stored in this file. So you are asked to use these variables as predictors of heat rate. So heat rate is response variable or dependent variable Y. Other variables are predictors or independent variables. And you are asked to construct scatter plot relating the heat rate to independent variables. Then, based on the graph, hypothesize a polynomial model. Okay, so that is the question. I'm going to use SPSS to do it. So first, I will open the data. This one. Okay, so I'm going to open the data. It is on my C drive. And then data file. So it is a CSV file. So I will select CSV. So the data file name is turbine, starting with T, alphabetically ordered. Which one? Let me check the file name. Oh, gas turbine. So starting with G. Starting with G. Gas turbine. Okay, so this is the data file. And then I click OK button. Okay, there are a lot of variables. So first, I will change the variable name to some variable name. For example, which one is Y? Y is the heat rate. So this one, I will say this is my Y underscore Y. Okay, and then we have other variables. We have other variables. So go to data view. Okay. So what are those variables? The risk not here. So the other variables measured cycle speed. Okay, cycle speed. I'll highlight so to cycle speed, inlet temperature, exhausting gas temperature. Those are X, so I have many X. Cycle pressure ratio and air mass flow rate. Air mass flow rate. So how many? 1, 2, 3, 4, 5. Okay, so there are 5 other variables. Maybe I want to move this over so that I need to identify these variables. So what are those cycle speed? PRM, cycle speed, revolutions per minute, revolution per minute. So this is cycle speed, okay, revolution per minute. Maybe to make things simple, I want to rename this one so that, so this one is my x1, and then next one is inlet measures. That is the temperature, inlet temperature. So this is my x2, okay, and then exhaust gas temperature. This is a x3, okay, and then cycle pressure ratio. Cycle pressure ratio, air mass cycle pressure ratio. Cycle pressure ratio is this one, cycle pressure ratio. So this is my x4, and then this is cycle pressure ratio, and then air mass flow rate, so this is x5. See, only identify the variables takes some time, okay, but that is the necessary step, so that you know which one is x, which one is y, okay. So 1, 2, 3, 4, 5 x, and I have 1 y, okay. So now I'm going to create scatter plot, okay. Go to graphs, legacy dialogs, and then scatter. So just use a simple scatter plot, define y, which one is y. So this time, see, after you change the variable name, this is y, very clear. Okay. So I'm going to create 5 scatter plot. So first is y versus x1. Okay. And then click OK button. Scatter plot. See, this is y versus x, okay, and this graph so looks like when you increase x, y also increase, and you can draw a straight line here. Looks like the linear relationship, okay, for this one. So now let me go back to do scatter plot between y and x2. So basically you repeat the same procedure, okay. So graph, legacy diagram, scatter plot, simple, define. Then I will remove this x1. I want to see x2. Okay, x2. Oops, x2 as x, and then click OK button. So this scatter diagram shows y and x2. This, when you increase x2, y decrease. So also looks like the linear relationship, say downward linear relationship. Okay. So continue to construct scatter plot between y and x3. So still y, but this time I need to use x3. So again, it is looks like downwarding. When you increase x3, y decrease. Okay, so let's look at y with x4 scatter plot. So I remove x3, add x4. And then click OK button. And this is x4. Okay, so remember x4 represents the CP ratio. Okay, this graph, when you see this graph, it is looks like a little bit curved. See this part a little bit curved, not a straight line. Okay, so I may model this variable as a quadratic. So in my model construction later on, see it is curved. Okay. And so this is this variable. Gas turbine. Do I have X5? Air mass flow. CP ratio. So where is the other variable? So go back to the data. X5 airflow. Okay, airflow. So now going to do the signal graph. Scatter plot. Then define. This time I need X5. Now I need to remove X4. And then X5. This one is looks like the downwarding straight line. Okay, you can draw a line here. Okay, so all of this kind of graph, this one looks like a little bit curved. Other scatter plot we can model using the straight line. Okay, so because of this reason, so I'm going to this is 1, 2, 3, 4, 5. Yeah. So I'll just make a label here so that it is clear. This is my X1. This is my X2. X3, X3, X4, and X5 is here. X5, okay. And so the model is, if this is X4, X5, okay, the other ones are linear. So my model would be, based on this graph, I will hypothesize a polynomial model. Okay, so the model is EY means the average Y equal to beta 0 constant plus beta 1 x1 plus beta 2 x2. I will omit until beta 5 x5 remember for x4, we said there is a little bit curve. So we need to say that beta 6 and then x4 squared. It is looks like a curve, quadratic curve. Okay, so this is the model. This is the model. So this is this question. Next question. This one is about emotional intelligence and team performance. Team performance. So what are the data? So students were enrolled in a course, Introduction to Building Industry, completed an emotional intelligence test and received interpersonal scores, stress management scores, and mood score. Students were then grouped into 23 teams, and each team received an average project score. 3 independent variables. Okay, x1 represent interpersonal score, x2 stress management score, x3 mode, range of mode score. And what is y? Y is a project score. Okay, y is project score. And then you are asked for question 1, 2, 3, 4. Question 1, hypothesize a complete second-order model for project score y as a function of x1, x2, and x3. 2, fit the model. Okay. And then 3, evaluate overall adequacy of the model. Question 5, is there sufficient evidence to indicate that x1 is significant? Okay, so those are the data. Those are the problems. Okay, so where is the data? Let me see the data. The data is the data name. I will type in the data name here. So data is TEAM team PERF. That is data name team performance. Okay. So now I will go open this data. Output. Maybe I wanted. So I just go to File. Maybe import data. My data is in CSV format. So I go to CSV. It is on my C drive. No, not that one. C drive. Then 442 folder exercise examples. The file name is team. Start with T. Team performance. Team perform is this one here. Okay, this is the data file. So I click OK button. Okay. So again, I will change the variable name so that it is clear which one is X, which one is Y, based on the description here. Okay. So I go to variable view, not this one. This is the one I just did, right? It is the other one. Which is, where is my file? Dataset 1. Not this one. This is not the one dataset. Okay. Look at it. Sync to the no. Changes no. Okay, try to open that dataset 2. Is this the one I opened? Yeah, this is the one I just opened. So just try to modify the name so that project score, that is Y. Okay, so this one is Y. This one is Y, and X1 represents, oops, intrapersonal score. Intrapersonal score. This is X1. Intrapersonal score. Stress management score. Stress management is X2. And the mode range of mode, X3. And what is this one? Rating encoded. Okay, so we have X1, X2, X3, and the project score Y. Okay, so I go back to the data. So I know what is X1, X2, X3, then Y. So now we are asked to set up a second order model for project Y as a function of X1, X2, X3. So second order. Okay. So remember, second order, you have to consider all the situation. Okay. Situation 1, X1, X2, X3 are linear. Situation 2, the interaction between among X1, X2, X3. Situation 3, the second order of X1, X2, X3. Okay, so the result would be this one here. Not sure if you can see clearly. E1 equal to beta 0 plus beta 1x1, beta 2x2, beta 3x3. Okay, so those are the linear part. And then interaction part, beta 4 x1 times x2, beta 5 x1 times x3, then beta 6 x2 times x3, and then the second order form x1 squared, x2 squared, x3 squared. This is complete second order model. Okay, complete second order model. And then question 2, how do I fit the model? Fit this model means, how do I find beta 0, beta 1, beta 2 until beta 9? Once I found those betas, the coefficient, I can write a model. Okay, so now this is the task. I'm going to use SPSS to fit this model. Okay, so to fit this model, first I need to calculate some new variables. Variable like x1 times x2, variable like x1 times x3, and then x2 times x3, as well as x1 squared, x2 squared, x3 squared. I need to compute those variables first. Okay. So to compute new variable, go to transform, compute variable. So variable name, I want to compute x1 times x2. Okay. Numerical expression is this is x1, move this, times x2. Okay, so x1 times x2. Click OK button. See, you have x1 times 2, x2 variable. So means 14 times 12, 14 times 12 equal to 168. Okay. Do the same thing for x1 times x3. So go to transform, compute variable. This time I want to compute x1 times x3. So x1, first I will delete, reset. So this time x1 times x3. Okay, click OK button. See, I have x1 times x3. And then you also need to do x2 times x3. So x2 times x3, and this one you need to delete x2 times x3. Click OK button. So I have x2, x3. And then you need x1 squared, x2 squared, x3 squared. Okay, so transform, compute variable. This time you need x1 times x1 means x1 squared. So x1, oops, delete this one. x1 times x1. Okay, that is x1 squared. And then do x2 times x2. Okay, so x2 times x2 means x2 squared. Click OK button. Lastly, you do x3 times x3. So delete this expression first. So modify this label. It is x3 times x3. So this is x3 times x3. Okay, so you have all the variables here, x3 times x3. Once you have this variable, and then go to Analyze, Regression, Linear. Dependent variable is y, and independent variable, I have x1, x2, x3, those are independent variable. I also have all of these are independent variable. So I press and hold down Control to select them all and move it here. Okay, so I better based on the order so that I consistent with my beta. This one I maybe I want to reset. So dependent, because I want to based on the sequence I set up in my model. Remember, the first one is x1, x2, x3. So I want to make sure those goes first. After that, and then it is those variables. Okay. Did I do correct? X1, X1, the sequence. Yeah, this time it's correct. Okay. And then click OK button. So it takes a long time to compute. Maybe this is the output. Yes, this is the output. Okay, so you get this output. So where is your model? All of this is your coefficient. Okay, so this 88 is your beta 0, and this negative 0.141 is your beta 1, negative 0.084 is your beta 2, etc. Okay, so those are your beta until beta 9 here, negative 0.001. So just plug those beta value, the coefficient, into the model here. Just plug in the value you get. So beta 0 until beta 9. Okay, this is the output from mini tab. I will compare if say this the beta with the SPSS that should have the same result. See, constant 88, negative 0.141, exactly the same number. Okay, exactly the same number here. So those are the beta. Okay, the coefficient here. Maybe I want to copy this, and then paste it into the OneNote to make annotation. So maybe I will put it here. I want to put the result here. Right. So this result, and this is my beta 0 constant. Next one is beta 1. Okay, until last one is beta 9. Okay, plug in those beta value into the model. You answered question 2. Fit the data into the model. Fit the model. Okay, and this is the model. Okay, so that is question 2. Question 3, evaluate the overall adequacy of the model. And for this question, you need to go back to the output. Where's my output? Try to find my output. The output. Yes, this is my output. The question is the model significant? That is question 3. To answer that question, you just need to look at ANOVA table, the p-value in ANOVA table. See, so this is the model, right? This is the model regression, and the p-value here is 0.731, 0.731. This p-value greater than alpha. Alpha usually 0.05 or 0.01 or 0.1. Regardless which alpha, this number 0.7 greater than alpha. When p-value greater than alpha, do not reject H0, means the model is not significant. The model is not significant because p-value greater than alpha. Okay. So this answered this question, question 3. Okay. And question 4 is sufficient evidence to indicate that X1 is significant. Test the claim at alpha 0.01 level of significance. So the question is, if x1 is significant. So to answer that question, you go, where is my, to answer that question, where is my, maybe I need to rerun the model because I need to see the this output not here. Need to pull out the data. Okay, so I'll rerun it. So analyze regression, then linear. Everything is all right. Just click OK button. All right. So I need this here coefficient table here. Okay. So to answer if x1 is significant, look at the p-value for x1. It is here. See, this is x1. The p-value for x1 is, see, 0.001, because this value smaller than the given alpha. When p-value is smaller than alpha, it is significant. Oh no, sorry, that is for constant. For the p-value for x1, it is 0.853. 0.853 is greater than alpha, so x1 is not significant. x1 is not significant. Okay. So that is question 4. Okay. And you can use other software to answer the question as well. All right, so this is this question. Last question here is about here. It's about the coding. Okay. Suppose you want to use the coding system for observational data to fit a second-order model to the tire pressure automobile mileage data below. So you have two variables. One is X, pressure. The other is Y, mileage. This is the data. And the question given, question 1, use the equation relating the coded variable U to pressure X using the coding system for observational data. Okay, so remember what is U? U equal to X minus the average of X, then divide the standard deviation of X. So this is answer A. This is a question A, 1. Then question B, calculate the coded value U. Okay. So you have to calculate X bar first. What is average of this X? And then calculate standard deviation of this X. Okay, so this time I'm going to use Excel to do it. So I already copied the data here. Okay. So this is my X. In order to do U need X bar. So I'm going to put X bar here. So equal average. Average of this number is X bar. And then I'm going to do standard deviation of X. So equal STDEV dot S. This is sample standard deviation of this number. Okay, is this one. And after that, so the u value is, this is x minus, this is x bar. This x bar is the same for all the data. So I press F4 button to change to absolute cell reference because this x bar is fixed for all data. And again, divide standard deviation. Standard deviation, I will use absolute cell reference because standard deviation is the same for all the data. Press Enter key. After that, I just use fill handle to copy down the formula. Okay, and I get the U. This column is U. Okay, so I did step 2. Question 2, calculate the coded value U. Okay, and then question 3, calculate the coefficient of correlation R between x and x bar, or x and x squared. So this is x. I already calculated. Now I'm going to delete to show you how do I calculate this x squared. Oops. So this is x. First, you calculate x squared, so equal this number square it. Excel use this represent square, okay? And then use fill handle. So this is x squared. And then correlation R, you use Excel, it is CORREL. It is CORREL. And then you select x, comma, select x squared, and press Enter. So this is the correlation between x and x squared. And then question 4. Question 4. Calculate correlation between u and u squared. So this is u squared. This is u. I'm going to create u squared equal to u squared. And then use the fill handle. Okay. So I will label this R is for x, correlation for x. And the next, what is the correlation coefficient? Correlation coefficient for u. Okay, so you type in equal CORREL. This is u, comma, this is u squared. Okay, the correlation is, maybe I will try to increase decimal place, format cells, because it is said format cells. It said 0. I just want to double check. Maybe I will. So it looks like it's frozen here. So maybe I will ignore that. Just accept it is 0. Okay. And then next question asks you to fit the model u1 equal to beta 0 plus beta 1u plus beta 2u squared. Okay. So you can use SPSS to do it, just as the one I showed you before. But now I can use, since I'm using Excel, I can use Excel to do it. So generally, I just change to number. Okay, so it is still 0. Okay. So now I'm going to fit the model. Okay. So to fit the model, I need the u. This is my u. This is u squared. Okay. And then EY. This is Y. I have to copy Y here. I forgot. This is my Y. Otherwise, I have no way to do it. So I need to copy this value is Y. So I just copy and then paste. This is Y. I should add label. Otherwise, I will insert. Okay. So this is my U. This is U times U. U times U. U squared. This is U squared. And this is Y. Okay. I try to see if I can use this. Okay. So now I need to fit this model. U squared. Y. So I go to data and then data analysis. After that, regression. Regression, click OK button. Input Y. This is my Y. Input X. These two columns are X. I have labels. Okay. And the result, I will put it is here. Click OK button. So this is my result. Okay. This is the result. So where is my model? See, this is beta 0, 37, beta 1, negative 0.46, beta 2, negative 5.33. Okay. So I will just maybe copy this. If I just move this a little bit up. All right, so I'm going to copy this and paste it into OneNote here. Maybe here. Okay. And then, so I can make a notation. So this 37 is my beta 0. Beta 1 is negative 0.46, and then beta 2. Okay. And then if I add additional question, the question is if the model significant. The answer is look at this p-value. This p-value is smaller than alpha. So the model is significant. The model is significant. And make sure you understand each and every number in this ANOVA table. Okay, check out my previous recording for multiple regressions. And also every number here is important. All right. All right. So I finished this one. In conclusion, in this lecture, I go over some problem to show how do you build a model using SPSS and using Excel. Thank you so much for your time.